everyone, welcome to this session number 313. And well, in this session I will explain this problem because yesterday I didn't understand why applies a few operation and this stuff, but now I understand and I would like to explain it. But yeah, basically it's this. The problem is this, yeah, you have a number of arrays. Even let me use the middle for explain it. Okay. Yeah, here for example. Okay, yeah, the idea is that you have an array with positive and negative numbers. You have k, and the idea is that return true or false if it's possible that create pairs with all these elements, yeah, that all the values should be, all the values or all the pairs should be divisible by k, yeah. In other words, it's basically in this k is 5, for example 4 plus 1 it's equal 5, and 5 is divisible between 5, yeah. Another is that for example this and this and this, for example 10 plus 5 it's equal 15, it's divisible between 5, yeah. This is the idea, and the point is that return true if I can make pairs with these numbers that all of them are divisible between k, yeah. This is the idea. Okay, now to resolve this problem, yesterday I had a half of the solution right. What is a half? Basically is get the module of the every element. For example, 1 module of 5. Why is the module? Because in this way we can know that the residual, and we can know if the number is divisible by k, yeah. In this case is 5. And another important point is that yesterday I noticed that a few solutions use a simple array of the size 5, in this case with these numbers, yeah. And why? Because in any moment this module should be greater than 5, yeah. It's interesting this because can help you to save a little memory. But well, basically is create a map, yeah. Do you imagine that this is a map, and in this is a mod, sorry, here is mod, and this is counter, yeah. This is the counter. Now for this is 1 module of 5. In this case 1 module of 5 is 1, yeah. Means that 1 appear 1, yeah. Now the 2 module of 5 it's equal to 2 appear 1. 3 module of 5 it's equal 3. 4 module of 5 it's equal 4. Sorry, here is 1. And the last is the next is 5 module of 5 it's equal 0. And basically the next that is 0. And for this is 1, 2, 3 and 4. 1, 2, 3 and 4. Okay, what is the important point here? we have two things to consider. The first point is that if you are using Java, C++, I think that except Python 3, you need to apply this trick with the module. And basically the trick is that the number n module of k plus k module of k, yeah, instead this, yeah, we should use this. Why? Because when you have negative numbers with this value or with this calculus, you can get a positive result, yeah. For example, if you have less 8, basically this less 8 it's 0, yeah, if you use a normal way. But in this way you can get a positive result, yeah, and it's not you can get the positive result with this, and with the positive values you get the normal value. For example, with the first is 1 module of k. In this case the result is 1 module of, sorry, he's 5, is 1 plus 5. This result is 6 module of 5, it's equal 1, yeah. And this is exactly the same that if we apply this, it's the same, yeah. But this formula or this calculus help us to handle the negative numbers. This is the first point. Now, the second thing that I didn't understand yesterday, and now I understand, is that in which moment you need iterate over these elements, right? And even you only need iterate between 0 and 5. No, in this case 4. Sorry. Yeah, only need this. Now, what is happening this? The first point is that the first point is that when the 0, when you have, for example, 1, you need the, try to imagine that this is an add operation. Using these values, you need get k, yeah, a plus b, it's equal this. We need try to replicate this operation, yeah. In this case k is 5, and we have the first number. The first number, for example, is 1. How many which number I need to use here for get this result? The 4, right? And basically is ask this number, the counter. Well, the first is that the counter is this, it's equal to, the counter is this, but other important thing is that here is validate, this exists here. If it doesn't exist, basically return false, yeah. Because in this moment we know that it's not possible to do the pairs, yeah, only for these cases, yeah. For example, this case exists, 2 it's equal to, in this case is this, is the value, not the key, yeah. Okay, you can continue, yeah. Now the other thing that, again, yesterday I didn't understand and now it's clear to me, is that what happening with this number. Because this 0, for example, for reach the 5, if you have a plus b, it's equal k, yeah, k it's equal this. Let me move this. Yeah, replaces this value a, it's equal 0. How many which number I need to get for have this result? The 5, right? But the 5 didn't doesn't exist here in this table, yeah, doesn't exist. And it's because basically when you have the zeros, yeah, for example here, you are saying that this number is divisible by key, yeah. Again, these numbers that in this case appear 2 and is this and this, yeah, the 5 and the 10, and basically means that these numbers are divisible by 5 for itself, yeah. For example, 5 module of 5 it's equal 0. But what means that? Means that this shouldn't apply this operation to search, for example, the one again. For a plus b it's equal k. K is 5 and the a, for example, is 1. We need search the complement. In this case the complement is 5. But for in the 0 it's not necessary search. We need only validate if the counter it's sorry, I confused the odd numbers. It's an odd number, right? No, even. It's an even number, yeah, because it's a pairs, yeah. This doesn't need search the complement because the complement is itself, yeah. For this reason, we need to apply this. Now, for resolve this problem, yeah, is for example, the first is that integer. We can use the map. But I think that if we know the size of this array, well, we can use the array result. It's equal new int. In this case, the int is k. Yeah. And next to is a for integer n array. And here is integer res. It's equal in the formula. The formula is n module of k plus k module of k, yeah. And here is basically result in the position, in the position res plus plus, yeah. And finally it's only apply a for, yeah, over these results. Okay, and no, here is wrong. Here, if I am handling okay, if I am thinking that if this is 10,000, I need iterate this for 10,000. No, I think that, yeah, in this case it's much better use this, or I can use a list and iterate by itself. Yeah, I think that list integer list is equal new array list. I am trying to avoid unnecessary operation here, and in this case is integer n list, but in this moment is list it's equal add this, but I think that this is much better with the hash set, yeah. And here basically is okay, if we have this or map, oh my gosh, what is Okay, our map is this: 1 have 2, 2 have 2, 3 have 2, 4 have 2, and 0 have 2, right? Okay, in this case is we have 1, 2, 3, 4, and 0. Yeah, this is the number that we have in this case. Now for this is okay, the first is get the complement. Complement it's equal and I need to do again this operation. But what happens if I am using this logic to, for example, k less n, and with this we have the complement, right? Because if k is equal 5 and n is equal 1, means that I need search the 4. Okay, this is the complement. Now the first thing is that if n it's equal 0, yeah, we need no, n if complement is k, n if result in the position, well, in this case is n, that means that 0 module of 2 it's equal 1, means that when is an odd value, sorry, I forget the odd numbers. Okay, when is a oh my gosh, odd number, right? Okay, odd number can make pairs, yeah, result false. This is only the special case. In other words, else if result in the position n it's different to result in the position complement, return false. Return true. Okay, let me check if it works. Yeah, but yesterday I had okay submissions here. Oh, it's done. Yeah, okay, I didn't submit because I don't want to submit because I didn't to resolve for myself. Now I know how to do. I would like to try to resolve in a few days or weeks, but well, for now it's enough. Okay, now what is this? Okay, the content, given an array of, okay, given an array of positive integers nums, remove the smallest subarrays possible empty such that the sum of the remaining elements is divisible by p. It is not allowed to remove the whole array. Okay. Return the length of the smallest subarray that you need remove or 0 if it's impossible. A superarray is defined as a contiguous block of the element in the array. Well, it's clear that we need to understand the previous problem related with the divisible by k for resolve this. And this was like a problem with the sliding windows, but I'm not sure. Let me check. Remove the smallest superarray possible empty such that the sum of the remaining is divisible by p, the minimal, the smallest superarray possible such that the sum of remaining. For example, this case is 3, 1, 4, 2, and p is 6. It's 1. The sum of the elements is 10. 4, which is not divisible by 6. We can remove the superarray 4, and the sum of the remaining elements is 6, which is divisible by 6. Now here is p, it's 9. I think that we need to remove this. We cannot remove a single element to get the sum divisible by 9. Yeah, because the sum is 9, 14, 16. The 16, the best way is to remove the superarray 5 and 2, leave us to with 6 and 3, that the result of the sum these values is 9, and 9 is divisible by 9. Now is 1 to 3. Well, it's okay because the sum okay, the constraints, the length it's at least 1 and is 100,000, I think, and the length and the values all are positive between 1 and this number, and p it's between the same range. Oh my gosh. Okay, well, my first thought related with this is could be I don't know if it's possible. Well, it's possible, but I don't know if we can have a linear solution, because my first idea is that get the total of the values in this case, oh, I forget put my chronometer. Now here, my first idea is get the result of the sum of the this. For example, this case is 4, 10, 14, 8, 10. Yeah, oh my gosh. Here the total of the this sum is 10. It's too much. Yeah. Okay, it's 10, and basically if we apply this over this, it's equal 4. Yeah, means that we need a superarray that have this sum. Yeah, and I think that we can do with prefix sum, maybe, or sliding windows. No, I think that is with sliding windows. When the number it's meanwhile the number is minor to, for example, x it's equal p no is total, that is the sum of the this element, total module of 6. When it's 0, it's returns 0. Yeah, it returns 0. Yeah, but when it's different, basically this is the number. In this case, total is 10, module of 6 it's equal 4, x it's equal 4. Yeah, and we need search this subarray in here. Yeah, now what is the way? Basically, meanwhile the number, or where the number is greater than 4, we need to move or slide the windows. Yeah, now for this, that the first number is 3, and well, at this point is R it's minor, well, it doesn't matter. Now the next stat is 4, and in this case is the number. I can return this. Yeah, but is the mean. I am thinking that, for example, if I have 1 1 1 1 4, even in this case it's only 1. Is this 4 right? Yeah, even in this case I was right. In this case, for example, is 3. 3 is minor to x, don't happen nothing. The next that is 4. Well, 3 plus 1 is 4. Okay, it's equal this. Is get this value. This case is 2, and continue with the next. The next is this. Now is 8. 8 is greater than this. Yeah, we need is linked the windows until reach the minor equal. In this case is until this point, and the size is 1. Yeah, I think that it's only that. It's a mix between, no, it's an sliding windows problem. Yeah, and all the numbers are positive, means that we don't need to use this trick with the module plus k or plus p, module of p. This stuff is not necessary, but in this case, integer L it's equal 0, integer right it's equal 0, integer mean it's equal integer dot max value. Yeah, and here again in this first solution I need to iterate over all the nums and get the total. Total it's equal 0. Come on. In this case is total plus equal n. Yeah, integer what is the name of my variable? X. Integer x it's equal total module of p, and here if x it's equal 0, return 0. In other case, we are searching this value in the sliding windows. For this is meanwhile R it's minor to nums dot length R plus plus. Yeah, and here I need another counter it's equal 0. Yeah, and here is counter plus equal R plus equal nums in the position R. Yeah, and here a while, and meanwhile counter is greater, I think it is greater equal, but let me check, greater than x. I need selected windows, in this case is counter, less equal nums in the position L, and plus plus. And here is mean, it's mean. Mean it's equal mat.mean between mean and R plus L, no. This R less L plus 1. Return mean. Okay, for example, in this case, we know that the total is 10. We start with the first, that is 3. 3 is greater than the x is 10. Yeah, x is equal 10. 3 is greater 10, sorry. X is equal 4 because it's the module. 3 is greater than x, no. Okay, this is wrong because I need yeah, this I need validate this only where when mean it's equal x is calculus this, and here if mean it's equal to this value, means that we need return less 1, other case return mean. Oh, okay. What is wrong here? Counter is greater than x. The first time is 3, it's not greater, but mean is not equal that x. Mean in this case is a maximum value, blah blah blah, and x is 4. Okay, now the next is 4. Well, if the next is 1, sorry, 3 plus 1 is 4. 4 is greater than 4, no, because are equal, means that this. I am calculus wrong. This total module of P. Why I am returning less 1? Mean it's equal x. What is the value of x? Should we have 4 and mean the second time? Should we have the sorry, here is counter, yeah, counter. Yeah. Okay, I think that should works. I will submit. Oh my god. Okay, what is happening here? Is 7 and I should be remove 1. Oh, because I can't remove all the array, and I think in this moment I am trying to remove all. The first is 1, no, 5, it's 1, 3, sorry, the total of this number is 6, yeah, 6 module of 7 is 6. In this moment reach the 6 and basically remove all the elements, yeah. And in this case how can I avoid to remove all the elements? I think that if X and L, let me check. Yeah, I can bet it's for this. Come on. Here. 0, 1, 2. Yeah, if L is equal 0 and YR reaches the 3. Well, when the sum of the L plus this is equal to the length of the array, is basically because we are removing all the elements, yeah. And here is if L plus R it's equal to nums dot length, or what? Array index of 3 of 3. In L in L it's minor equal R. I output less 1 and I hope this is for this reason. Here is 3. Okay, let me check. Calculator module of which number are 3. It's 1. Output less 1 and I expect 0. Oh, I think that is for this total should be the long. Is for this, sorry. This is long. Oh, come on. Okay, let me check the result of this. The result is less 1 is 3. Why less 1? okay, it's not for this. The mean, yeah, it's basically for this reason. Counter, oh, in here, I think that I should use the long here, not for this case, but I am thinking that for the other case that have a bigger numbers, it's necessary to do this. Now works. Sorry. What is happening here? Basically, counter is not greater than x, but counter in x it's equal this. Let me check here if appear another cases. Here. I need another short case. Is 74. Well, I will put another one here in. What is happening with this? Appear here. Why return less 1? I have 26. Okay, let me copy this. Here we have a ping. Oh my gosh, I have only 10 minutes more. 26. What is the total of the sum of this? Let me check. Is 26 plus plus 8 plus 10 plus 6 plus 26 plus 3. The total is 2. Okay, again. Plus 19 plus 11 plus 14 plus 18 plus 4 plus 7 plus 1 plus 13. $225. Okay, 225. This is the total. Now this total, sorry, this number 225 and the module is 25. It's 25, right? No, 26. And this is 25. The module is 17. Yeah, and when we search here, the 17. Here I need to search the 17. Is 4 plus 6, no. What is the result? The expect 3. No, because we are searching this number. No, this no, this no, this no, this no. Okay, I think that is wrong. In this case, it's wrong my approach because I don't see any. For example, this, no. This, no. This, no. This, no. This, no. What is happening if I remove this? It's 5, it's 12. Okay, I think that if the total is 225, I should be apply this 26. It's possible, no. I don't know. Is here. Okay, let me check what is the topics. Okay, if we have the total and is total less this is living windows when the total 225 less 26 is equal 189. This module of 26 it's 17. If I remove this, oh no. Okay, it's 26 is 17. We are searching the 0. Okay, means that I need add more elements. Now the next step is this 26 plus 19 it's equal 30 30 39 45, right? Is 45 225 plus 45 in this case okay. Now this operation is 100 80 is 24. The previous was 17 and now is this means that I need add another element. This case is the 11. 26 plus 19 plus 11 it's equal 45 is 60 56. Yeah, in this case is the total that is 225 less 56 is 100, sorry, 169, and is 169 between this 169 between this is a 13. But mm, 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 mm. I don't know. Okay. Which number I am searching? If I have the total that is 225, and we have the module, the p that is 26, is that which number? Okay, the first one is search the module of is this number, or this number that is the total minus this, and if the module is equal 0 means that is the subarray. But who know the size of this subarray? Meanwhile, it's greater. I think that where the sum of the prefix sum less this number of module of p is negative. No. Okay, let me check the comments. Yeah, me too. And even in my case, I can't do it with this problem. Yeah, this case is the okay. Let me check this step. If I is b modulo p equal k, oh my gosh, b modulo p is equal k. Okay, only 3 minutes more and it's enough. Tip. No, I don't want the solution. Not yet. Yeah, I was trying to resolve it this way, but instead to check for exactly superarray, you should by search for superarray that modifies the remainder of the sum when divided by b. You should be searching for an superarray that modifies the remainder of the sum. Modifies the remainder. Checking for the exact sum array sum that I am trying to do this, you should be searching for a subarray that modifies the remainder of the sum. In this case is 17 when divided by p. I don't understand. You should be searching for a subarray that modifies. For example, in this case is 225, and I think that is this operation less 26 is 199. The module of this, what was the result? Was 20, no, it's 17. No. Okay. I think that was this. Let me check the code. Okay, total sum. Wow. Where is this? Total modulo p. 0 plus 26 modulo of p. Okay, target it's equal total sum modulo of p, it's equal 0. Now is handle the case where the whole prefix is the answer. Okay, current sum it's equal 0, new length, and is iterate over the array. Current sum it's equal current sum plus, well, it's the prefix sum modulo p. Why always modulo p? I needed current sum less target. What is target? Is this Let's target plus p modulo p. Okay, if we have seen the neither romantic, we can see. Yeah. um, well, it's an interesting question, but yeah, I think that this. Okay, I will check in the next session the solution for understand completely. But well, thanks for following this transmission, and I will see you more late.